All right, welcome to chapter 5.5, performing function operations. Essential question: how can you use the graphs of two functions to sketch the graph of an arithmetic combination of the two functions? Okay, so just as two real numbers can be combined by the operations of addition, subtraction, multiplication, and division to form other real numbers, two functions can be combined to form other functions. For example, the function f of x equals 2x minus 3, a line, and g of x equals x squared minus 1, a parabola, can be combined to form the sum, difference, product, or quotient of f and g. So when you add them, you'd get a parabola. When you subtract them, you'd get a parabola opening down. When you multiply them, you'd get a cubic function. And when you divide them, you'd get a rational function. So what you will learn: add, subtract, multiply, and divide functions. Fun. Okay, so operations on functions. You have learned how to add, subtract, multiply, and divide polynomial expressions. These operations can also be defined for functions. So the core concept in this section is operations on functions. So you let f and g be any two functions. A new function can be defined by performing any of the four basic operations on f and g. So an operation of addition would give us f plus g of x equals f of x plus g of x. So f plus g of x equals, for example, if f of x is 5x and g of x is x plus 2, f plus g of x would be 5x plus x plus 2, which is 6x plus 2. If we subtract them, then we get f minus x equals f of x minus g of x, or 5x minus the quantity x plus 2, and that would equal 4x minus 2. Multiplication of functions, so we would say f of g of x equals f of x times g of x. So f of g of x is f of x, which is 5x, times x plus 2. And when we distribute, we get 5x squared plus 10x. Okay, so that was two linear functions creating a different linear function in the adding and subtracting. But when you multiplied it, it became a quadratic. Now when we divide f of g of x, f of x divided by g of x is the same as f divided by g of x. So now we would have 5x divided by x plus 2. But in this situation, as it says down here, g of x cannot be 0. In other words, I can't let x equal -2. So the domains of the sum, difference, product, and quotient functions consist of the x values that are in the domains of both f and g. Additionally, the domain of the quotient does not include x values for which g of x is equal to 0. So what they're saying is any value that you can plug into one, you can plug into the other, or what if there's whatever the domain is in f and whatever the domain is in g, then the domain of f and g would combine to be the domain of the new operational, or the function that the operation was performed on, except dividing. We can't have x equal -2 in this case because you can't divide by 0. Okay, so let's do some examples. Okay, so now we have example 1, adding two functions. So it says let f of x equal 3 times the square root of x, and g of x is -10 times the square root of x. And they're asking us to find f plus g of x. So the first thing I would write is f plus g of x equals f of x plus g of x. Okay, and if I go back here, we're just doing this right here. Okay, f plus g of x is the same as f of x plus g of x, and all you do is take the one function and add it to the second. So let's do that. So f of x is 3x. Let me highlight these and use colors. So let's use green. 3 square root of x is f of x. So I'll use a green pen to write that. So that's going to equal 3 times the square root of x. And then we're going to add, and then g of x is -10 times the square root of x. So g of x is -10 square root x. So we're adding these two. square root of 3x plus a negative 10 square root x. And when we're adding square roots with the numbers outside being different, our coefficients, if you will, then that would be just taking this 3 minus 10 and getting negative 7, and the square root of x just comes along for the ride. So there's the answer. That's what f plus g of x will become. And then it says to evaluate the sum when x equals 4. So now I have f plus g of x is this. So now I want f plus g of 4. And that's just going to be when I substitute in a 4 for x. And then I simplify. Square root of 4 is 2, and negative 7 times 2 is negative 14. So f plus g of 4 is negative 14. Okay. So that's how you do adding of two functions and finding a value of the new function. Okay, so now that I've done this algebraically, I wanted to show it to you graphically. So we have this function here. I'm going to graph in green and this one in blue, and I'll do the combination of the two, the sum of the two in red, and then we're going to find what f of 4 is, or when x equals 4. And I did it in Desmos. So here it is. So this green one is 3 times the square root of x. That's f of x. G of x is the red one, which is, no, it's a blue one, negative 10 square root x. And when we added them, we got h of x. So I can't call it f plus g of x. This program does not identify that, but h is f plus g. So I got negative 7 square root x. And then I drew a line, x equals 4, and that is right here. So in the original equation, f of x, f of 4 was 6. In g of x, f of 4 was negative 20. But in the combination of the two, the function value when x is 4 was negative 14 right there. Okay, so that's what it would look like graphically. The two original functions, the sum of the two, and a value on that new function when x equals a certain value. Okay, I just wanted to show you the picture of that. Okay, example 2 is subtracting two functions. So let f of x equal 3x cubed minus 2x squared plus 5, a cubic, and g of x equals x cubed minus 3x squared plus 4x minus 2, another cubic. So we're going to find f minus g of x, and then state the domain, and then evaluate the difference when x equals negative 2. Okie dokie, so here we go. I'll just use black, I guess. So I want to find f minus g, and this is how you show your work. F minus g of x equals f of x minus g of x. So that's going to equal f of x, which is 3x cubed minus 2x squared plus 5. And I'm going to hit minus, right, minus, and then I'm going to put parentheses here because I'm subtracting the whole thing. So all these signs are going to change. X cubed minus 3x squared plus 4x minus 2. Okay, so the book shows it horizontally and they don't do the distribution, but I like to show this. This is now going to become 3x cubed minus 2x squared plus 5. And then I'm going to distribute this negative 1. So it's going to be minus x cubed. Distribute this negative. A negative times a negative is positive 3x squared. A negative times a positive is, again, now that one's negative. 5 times 4, or I'm sorry, it's not the 5, it's the 1. So it's just negative. The sign just changes. Negative times a positive is negative 4x. And a negative times a negative is positive 2. Okay, so now I'm going to combine like terms. So 3x cubed plus 3x or minus 3x cubed. So 3x cubed minus 3 or 1x cubed is 2x cubed. Let me change colors now. Minus 2x squared plus 3x squared would be plus 1x squared, or just plus x squared. I don't like to write the 1. So I'll just put plus x squared. And then finally, minus 5. And I have an x here, so don't forget that. There's no x here, but there is over here. So that is going to just be minus 4x. And then I have a constant plus 2. Okay, so 3x cubed, 3x. Oh, there's a 5 here. 5 plus 2 is 7. My apologies there. I should have underlined this 2 here. So the 3x cubed minus x cubed is 2x cubed. Minus 2x squared plus 3x squared is 1x squared. There is no linear term over here, so be careful and just bring that down. And then finally, plus 5 minus 2 or plus 2 is plus 7. Okay, so I got 2x cubed plus x squared minus 4x plus 7. Another way we could do that, I'll just show it real quick. 3x cubed minus 2x squared plus 0x plus 5. So I'm going to write it like this, and then down below I'm going to subtract the whole thing. I'm going to subtract x cubed minus 3x squared plus 4x minus 2. This way might be easier for you. So 3x cubed minus 1x cubed is 2x cubed. Negative 2 minus a negative is plus. So negative 2 plus 3 is 1x squared. 0 minus 4 is negative 4x. And 5 minus a negative 2 is 5 plus 2, which is 7. So we get the same answer, but I kind of prefer doing it vertically. And then I don't have to change all the signs and then add. Okay. Now it says then evaluate the difference when x, state the domain, by the way. Well, it's a cubic. Cubic functions, when graphed, are a continuous function. A is positive, so it is going to look something like that. So it's going to go to negative infinity forever and positive infinity forever, and there is no x value I can't plug in. So the set of all reals. So the domain is all reals, which we draw like that, or you can say negative infinity to infinity. And put them in parentheses like this. Okay, so the domain can either be all reals or this. So I stated the domain, and now I want to evaluate the difference when x equals negative 2. So I want to find out. So now I have a function f minus g of x. Let's call it h of x. So now I have the new function h of x equals what I got right here. So let me just drag that down. I think they're all different pieces, so might as well just write it. So it's 2x to the third plus x squared minus 4x plus 7. And I want h of negative 2, which means make all the x's negative 2. Okay, so that's going to equal negative 2 cubed is negative 8. And negative 2 squared is 4. And negative 4 times a negative 2 is a positive 8 plus 7. So this is going to equal negative 16 plus 4 plus 8 plus 7, which is going to be negative 16 plus 4 is negative 12 plus another 8, negative 4 plus 7 is a positive 3. Okay, so h of x, which is actually f minus g. I just called it h of x here. F minus g of x. I'm sorry. F minus g of negative 2 is 3. Okay, so that's how you subtract them. So after doing example 1, which was addition, and example 2, which is subtraction, you should now be able to do 3, 4, and 6 on your assignment. Okay, so we've added, we subtracted, now we're multiplying. Example 3. Okay, so here we go. Let f of x equal x squared. Let g of x equal the square root of x. Find f times g of x and state the domain, and find the product. Evaluate the product when x equals 9. So I'm going to say f of f times g of x equals f of x times g of x. That's a dot, not a minus. All right, so f of x is x squared. And I'm going to multiply it by the square root of x. Okay. What is x squared times the square root of x? Let's see. I'm kidding. Okay, so I want to change this to a rational exponent. So I'm going to do x squared. And remember, this is a 2 here, and that is a 1 there. So that's going to be x to the 1/2. Okay. And remember your rules. When the bases are the same, you keep the same base and you add your powers. So it's 2 plus 1/2. So that is going to be x to the 2 plus 1/2 is 2.5, which is 5/2. Okay, so my new function f of g of x is x to the 5/2. Okay, which means x to the 5th, and then take the square root, basically. Okay, so then they evaluate the product when x equals 9. So I want to find f of g of 9 is going to equal 9 to the 5/2. Okay, and remember what I said. That's the same as taking the base. This bottom number is your index, and the top number is your power. And you do not need to write this 2 here, but I just wanted to show you that's where it would go. So that's what it looks like. It's the square root of 9 to the 5th power. So another way of writing this, you always want to make numbers smaller if possible before making them bigger, because 9 times 9 times 9 times 9 times 9 is really big number. Then you need a calculator to find the square root or do a really long factor tree. If you do it this way, the square root of 9 and then take the 5th power outside, then do what's in the square root first, that would become 3 to the 5th. 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. So you can do it without a calculator, hopefully, if you go smaller before you go bigger. Okay, so f of g of 9 is 243. I haven't stated the domain yet. Okay, so remember, this is the same as x square root of x to the 5th, and 5 is odd, so a negative will become negative when you take it to an odd power. So I can't have the square root of negatives. So my domain is x is greater than or equal to 0. That is my domain. Okay, so that is problem number 3, example 3. Example 4 is dividing two functions. We've done addition, subtraction, multiplication. Now here's division. So we're going to divide f over g. So I'm going to say f over g of x equals f of x divided by g of x. I'm going to go horizontal here. F of x is 6x. That is a line. So the domain of f of x is the set of all reals. Okay. And the range, I'm sorry, not range. And then the domain of g of x is x to the 3/4. Okay, so x to the 3/4 is the same as saying the cubed root of x to the 4th. No, it's not, just kidding. It's a 4th root of x cubed. The denominator is your index. The numerator is your power. And since you can't take the 4th root of a negative is imaginary, so we only can have positive numbers in this. So x is greater than or equal to 0 is the domain of g. So f is all reals, g is all x's greater than or equal to 0. So the domain of a function that you combine, two functions you combine into one, is going to be the domain of the restriction on the first two. At least it could be smaller. So in this case, it is going to be smaller. I can't have 0 in the denominator. So now I know that without even doing this, my domain for f over g of x is x greater than 0. It has to be positive and it can't be 0 because 0 is undefined. Okay, so now let's, I don't want to leave this as x to the 3/4. Remember the rule. We can rewrite this as 6 times x over x to the 3/4. Okay, and this is x to the 1. And the rule for division means to subtract your power. So that would be x to the 1 minus 3/4. Don't forget my 6 out in front. And so that's going to simplify to 6x to the 1/4. So that is the 4th root of x. Okay, if I wrote it that way. Now I want to find f divided by g of 16. Okay, so that's going to equal 6 times 16 to the 1/4. Well, if I rewrite that as a radical, that'd be 4th root of 16 to the 1st power. Okay, 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the 4th power is 16, so the 4th root of 16 is 2. So my f over g of 16 is going to equal 12. Okay, so that's how you do division. Be careful with your domains, be careful with your rules. And that's how you divide two functions that are radical. All right, so after doing the multiplication example 3 and the division example 4, you should be able to do 7, 8, and 10 in your problem set. Okay, example 5, performing function operations using technology. So it says let f of x equal the square root of x and g of x equal the square root of 9 minus x squared. It says use the graphing calculator to evaluate these when x equals 2 and round your answer to 2 decimal places. Okay, so that's the key here. Please read directions. So when it says to round, you round to where they say. This could make a big difference on a standardized test. If you don't round to the right decimal place, you get the question wrong. All right, so first of all, I want to do this manually. So f of x is the square root of x. And if I'm doing f plus g of x, and g of x is that, then it'd be x plus 9 minus x squared square root. So that's just f of x plus g of x. They didn't ask us to find the new function. They just said find the value of the new function when x is 2. So that just means to plug in 2 here. And this would be the square root of 9 minus 2 squared, which is 4. So the square root of 2 plus the square root of 5. Well, I'd have to do decimal approximations to find out what these are worth, or the values of them. So I'm going to use the calculator now. So I'm just going to take the square root of 2 plus the square root of 5. Oops, I didn't come out of my square root first. Let me do that over. Clear. Square root 2, I got an arrow out of it. What's this L2? Square root 2. Arrow out. Plus square root 5. Get out of it. Enter. That is approximately 3.6. And then look at your third decimal place, less than 5. You just cut it off. 3.65. Okay. So that's f plus g of 2. So I should write that. F plus g of 2 is approximately 3.65. Okay. All right, so now we're going to do the minus 1. F minus g of x. So that's just f of x minus g of x. We want to find f minus g of 2. So it's going to be the square root of 2 minus 9 minus 2 squared. So the square root of 2 minus 2 squared is 4. 9 minus 4 is 5. We're just going to get the same values here, just a minus sign in between. And now I just go square root 2, get out of it, minus square root 5, enter. And I get f minus g of 2 is approximately negative 0.821. 3 decimal places is a 1, so that just stays 0.82. Okay, that's f minus g of x. And the third one, f times g of x, that's the square root of x times the square root of 9 minus x squared, or the square root of 2 times the square root of 5, which is the square root of 10, or is it? So let's see, the square root of 2 times the square root of 5, enter. So I now know that f times g of 2 is 3.162. The 2 is going to make that 6 stay. So it's 3.16, and I use an equal sign. Whoops. That is not an equals. When I round, it's now an approximation. Okay, so let me just check that and show you if I do square root 10. Is it the same decimal place? Sure. So whenever you have two radicals and you multiply the radicands, you get that. And that can actually simplify, can it? 10, 2 times 5? No, it can't. Square root 10 does not simplify. So it is the square root of 10, or 2 times, square root of 2 times the square root of 5. Okay, moving on to the next one. F divided by g of x is going to be, actually, no, I don't want to write that. F over g of 2 is going to be f of 2, which is the square root of 2 divided by the square root of 5. Now, if I wanted to rationalize that first, let's practice that. We want to get rid of the denominator's radical. That's called rationalizing the denominator. We're going to get the square root of 2 times the square root of 5, which is the square root of 10 over 5. So this is what I'll put in my calculator. So I'll check the other one too, though. So it's the square root of 2 divided by the square root of 5. And I got 0.6324. Now, if I put the square root of 10 and divide it by 5, do I get the same number? I do. So f of g of 2, let me move this down, is approximately 0.63. Okay, so that's how you use a calculator to do function operations using technology. All right, so now you should be able to do problem numbers 13 and 14 if you have one of these calculators. Okay, example 6, solving a real life problem. So now we're going to apply this to a real scenario. For a white rhino, heart rate R in beats per minute and lifespan S in minutes are related to body mass M in kilograms by the functions R of M, okay, heart rate per minute equals 241 times M to the power of negative 0.25, and S of M, which is lifespan of a certain sized rhino, is 6 times 10 to the 6th power quantity times M to the 0.2. So A says to find R times S of M. So R times S of M equals R of M times, R of M times S of M. Okay, so R of M times S of M. And then we're going to substitute in what those are. So R of M is equal to 241 M to the negative 0.25. And I'm going to take that and we're going to multiply it by S of M, which is 6, that's a parentheses, 6 times 10 to the 6. Okay, that's scientific notation. That's the only time we use an X now with multiplication. That's 6 times 10 to the 6. That's scientific notation. Times M to the 0.2 in a bracket like so. Okay, so that is R of M times S of M. And what we're going to do now is multiply all of this. So the first thing I'm going to do is this 241 just stays out in front. And M to the negative 2, I'm going to bring this out now. I'm going to bring all the numbers together. 6 times 10 to the 6 is going to go out in front. And then multiplying M times M, I'm just rearranging this, is going to give me the same base of M. And it's negative 0.25 plus 0.2. So I'm going to show that negative 0.25 plus 0.2. Remember your rules. When you multiply the same base, you add the exponents. And this is going to simplify to 241 times 6 times 10 to the 6 times M to the negative 0.05. Okay. So now I can multiply or get the same basis. So 241 times 6. So 241 times 6, 6 times 1 is 6, 6 times 4 is 24, carry the 2, 6 times 2 is 12, plus 2 is 14. So now it's 1,446 times 10 to the 6th. And this whole number now is multiplied by M to the negative 0.05. Okay, so let me just scroll a little for more room. And then what I'm going to do is I'm going to use the scientific notation here. And I want the decimal. Remember, scientific notation is the number in front of the decimal is between 1 and 9. It can't be greater. So if I have a decimal here, obviously 1,446 is greater than 9. If I put the decimal here, 144 is greater than 9. If I put the decimal here, 14 is greater than 9. And if I put the decimal here, I now have a number between 1 and 9 inclusive, so it's 1.446. So I'll put that decimal there. 1.446. Well, I moved it 1, 2, 3 places. So that's going to add 3 places to 6. And now that's 10 to the 9th power. Times M to the negative 0.05. Okay, so that is the answer. That's what R times S of M equation would be. Explain what R times S of M represents. Okay, so let me bring that in. So it's multiplying the heart rate by lifespan, which gives the total number of heartbeats over the lifetime of a white rhino with a body mass M. So then if we know what the weight of the rhino is, we would substitute in for M and see what their total number of heartbeats over their lifetime would be. Okay, so that's how you do a real life scenario problem with multiplying 2 different functions. So now you should be able to do problem number 19 in your problem set. Okay, so that brings us to the end of chapter 5.5. Here are the exercise problems I assigned. So go to it, and thanks for watching and have a great day.